Neon. Neon is a chemical element with the chemical symbol Ne and has the atomic number 10. Elements that have common properties and characteristics are placed into groups in the periodic table. In the periodic table of elements, neon is placed in group 18, which is also known as noble gases. All the gases that are found in group 18 all fulfill the octet rule with 8 electrons in the outer shell except for helium, and all the gases can also be found in air. Neon is placed in period 2, which means that neon has 2 shells. The element classification for neon is nonmetal. Neon is a colorless, odorless, and a tasteless gas, but even though that neon is a colorless gas, it glows bright orange-red if an electric current passes through it and create an electric discharge, and this is also why it's being used for neon lights. The atomic structure of neon. The nucleus consists of 10 protons and 10 neutrons, and 10 electrons bind to the nucleus by shells. It has 2 electrons in the inner shell and 8 electrons in its outer shell, which makes this atom stable. The atomic mass for neon is 20.18 unit, and neon got 19 different isotopes, which mean that 20.18 unit is the average weight of all those isotopes together. Neon possesses 3 stable isotopes, which is neon 20, neon 21, and neon 22. The chemical properties of neon. When we have neon at room temperature, the state of matter, it is a gas. The melting point for neon is minus 240.59 Celsius, and the boiling point is minus 246.08 Celsius. The solubility for neon is that it's soluble in water. The reactivity for neon is inactive, and the reasons to why it's inactive is because neon typically does not bond with anything because it's a noble element, and they do not like to bond with other elements because they already have what they want, a full outer shell of 8 electrons. So, since neon is chemically inactive, I've chosen for this video for my experiment to create sodium carbonate from sodium bicarbonate. The chemical equation that I get from this experiment is NaHCO3, which is in a solid state, and that gives Na2CO3, which is in a solid state, plus CO2, which is in a gas, and H2O, which is also a gas. This equation is not balanced. In this experiment, you will start off by weighing 250 grams of sodium bicarbonate and put it in a pot. The pot that you see in this video is placed on a stove at medium to high heat. At the beginning, before any change takes place, this is what the texture will look like. As the sodium bicarbonate heats up, it will start to release water and CO2. So due to the water, you might notice some clumping starting to occur. Soon you'll see little geysers of CO2 gas and water being released. Because of all the gases being generated, it will puff up the baking soda, and when you stir it, it will look almost like a liquid. As when you do this, the amount of gas that is being produced will start to decrease. Soon you'll notice that no more gas is being released, and at this point all this sodium bicarbonate has been converted into sodium carbonate. And the product you get at the end of this experiment is 150 grams of sodium carbonate, which is nearly quantitated. So to balance this equation, we look on this chemical equation and we make a reaction scheme, and what I can see is that we have 1 sodium, 1 hydrogen, and 1 carbonate on the left side, and on the product side we have 2 sodium and 2 carbon and 6 oxygen and 2 hydrogen. So what we have to do is that we have to add a 2 in front of the sodium bicarbonate, so we get a balanced equation. During cosmic nucleogenesis of the elements, large amounts of neons are built up from the alpha capture fusion process that happens in stars. The alpha process is one of the 2 classes of nuclear fusion reactions by which stars convert helium into heavier elements, and one of them is neon. Although neon is a very common element in the universe and the solar system, it is very rare on Earth. It is the 4th most abundant element in the universe. However, only 0.0018% of Earth's atmosphere is made of neon. The reasons for neon's relative scarcity on Earth is because neon is highly volatile and forms no compounds to fix it to solids. Neon is also lighter than air, causing it to escape even from Earth's atmosphere. Neon was discovered by Sir William Ramsay and Morris Travers in 1898. It was discovered through the study of liquefied air. It was discovered when Ramsay chilled a sample of air until it became liquid, and then warmed the liquid and then captured the gases as they boiled off. The name neon is derived from the Greek word neos, and meaning new. The part where we see neon in our daily lives are when we see neon lights, as for example the Las Vegas sign is made out of neon lights, and this is where the gas neon is being used. A neon light is a sealed tube filled with low pressure neon gas. And the workings of this is that the electrodes ionizes the gas with high voltage electricity. We have an electrode at each end of the tube, and an electric contact connects a tube to electricity supply. And then here we have the electrodes ionizing the gas. The electricity and the neon ions flow in the same direction from one electrode to another. The neon ions move around very randomly, and then the electrons move in like the opposite direction of the ions. So, when noble gases collide with ions and electrons, they become unstable, and consequently rid the absorbed kinetic energy by giving off photons. So when we have this collision between neon atom, neon ion, and electrons, they kind of expel colored photons, which create this